Digital Initiative Seminar of the year. And we have all three authors with us today, which is such a pleasure. Martin, Noam, and David will present their very, very interesting work about the growth of AI in China, and understand it's part of a larger agenda. So we're going to see a big piece of that today. And just really, I thought the data is amazing. So I'm looking forward to seeing it again. Okay, guys, take it away. As you know, the floor is yours, and you can handle the questions any way you like.
Awesome. Thank you so much for having us. So I'll be presenting, but I'll let Martin and Noam chime in when there are hard questions. So let me try to share my screen. Can you guys see well? Okay, perfect. So as Jim was saying, this project is trying to understand AI sector in the age of data-intensive innovation, which in particular interested in understanding the relationship between government data and the sort of the innovation in this sector. We're going to show you some evidence from the facial recognition AI sector in China, and I want to broaden the scope to think a bit conceptually about what this implies. Okay. And feel free to sort of interrupt throughout the talk, and I'll also pause after every couple of slides just to collect questions. But feel free to just interrupt in the econ style talk. Okay. So I want to start by motivating that sort of as economists and across social scientists have been sort of painting or suggesting for a while, the innovation in AI is a special sort of it's a particular kind of sector of innovation because the sector is data intensive. And by that, what we mean is that the development of new products, new technology in the sector not only hinges on the accumulation of capital and human capital, but also the accumulation of large amount of data. And think about sort of the headline sort of technology that's developed in the AI sector in the last couple of decades: facial recognition, speech recognition, mastering chess, translation, and so on. All these are development in AI that build on algorithms that exist for quite a while, but really took a leap into the innovation application of the technology because of the recent collected large amount of data. Okay. Up until now, sort of the literature in economics in particular has primarily focused on the role of private data, or the data collected by private firms, and how those data has been shaping the innovation of AI. Yet, sort of, if we look back in history, and certainly this is going to be hold true all the way until today, one of the big players of collecting and potentially sort of distributing data is the states, is the government. The government has been playing an important role in collecting a huge amount of data, and primarily as a way to fulfill a lot of the sort of functions, the key function that we associate with the state. Okay, so give you a couple of examples that the government data that's been collected to fulfill a certain role of the state has already been used by AI firms, and has already been used sort of by the innovators in the AI sector to develop the AI technology. So think about sort of administrative health records that has been used for medical diagnosis, that's used by medical AI applications, and we see increasingly more so of this since COVID. Geospatial data, satellite data, for example, to detect mineral resources collected by the government has been used by many of the AI firms. Radar data of all sorts that's used for meteorological predictions, again, are sort of one of the key input into services such as Google Maps and some of the services for Google AI. And what we're going to focus a bit more empirically today, and a lot of this is more salient in the news that you see as sort of the video data that's collected by public surveillance cameras that's being used by facial recognition firms. Okay. So what we're trying to do in this project is try to both empirically and also conceptually try to understand the way in which government data collection and government data sharing can and how it could shape the AI innovation, in particular the commercial sector of AI innovation.
Yeah. So can I jump in, David, and ask a question?
Yeah.
Are you going to separate commercial AI innovation which is to say that, are you going to separate that into, and this seems pretty important, especially given the data that you have, into privately held AI innovation and publicly available? And so, of course, the ideal would be if I can access as much data as possible as a private individual or firm, and then access it, use it to train my model or to like develop the most cutting edge AI I can. And then I can capture all the rents of that, right? Which is I never have to tell anyone. I can commercialize it and capture 100% of the commercializability. And in that sense, that may push a ton of AI innovation, but AI innovation that is privately held by one company, right? Or by a few companies, as opposed to like generalized AI innovation that society can use to increase the, in some sense, that distributed welfare in a different way. Are you going to care about those two, or just AI innovation's one big blob?
Yeah, so that's a great question. So there are two sort of big picture comments on that question. The first one is, as you said, sort of the distinction between commercial and government innovation for commercial purposes and innovation for government purposes or public sector purposes, broadly speaking, is a key distinction, and which is sort of underlying sort of the core of the mechanisms that we're going to tell, which I'll give you more detail in the next slide. We are, however, for the most parts of our empirical analysis, at least, is going to abstract away from a cross-firm distribution or the industrial organization aspect of this. So we're going to thinking about within a particular firm, the extent to which my government data can allow me to innovate not only for the government, but also for the commercial side. And then you can think about a lot of the adding in the industrial organization aspect of the market structure and so on to have this cross-firm aspect of this. And which that part sort of in the sense of like non-rivalry of data and so on has been studied, at least theoretically, by folks such as Joan and Tonati, which we're going to sort of abstract away from.
But are you going to care about, even abstracting from that, are you going to care about the rents that can be captured by the person innovator or not?
So we want to care about within the firm. By rent, to the extent you mean that the rent is if the firm receive government data and the firm is just essentially sort of maximize the payoff of that government data can generate in terms of the output, regardless of the particular sort of sector that the initial access to government data is meant for, we're going to be able to capture that empirically. And we're going to sort of, when I say we're going to abstract away from that empirically about a cross firm, but we are going to have some discussion about this sort of when I show you towards the end of the talk about the conceptual framework or the model, we're going to allow for some aggregation of the government provides data to multiple firms simultaneously and so on. Okay, so we can come back to this question, I guess, when I show you our empirical setup and what's being shut down by our empirical strategy and what's not. And to the high level, think about a lot of analysis is going to be within firm, which we think is better identified. Okay. So get back to the initial motivation. The two specific questions that we're after in this paper is the following. The first one is, we want to understand how does government data shape data-intensive innovation, and then what are the consequences and trade-offs that are involved in various forms of government or state policies that involved in data provision, data collection, and procurement of data-related technologies in the economies that's getting increasingly data-intensive. Okay. To answer the first question, I'm going to highlight, and this is get back a little bit to Lauren's question earlier. I'm going to highlight a specific and a quite precise mechanism through which government data can actually affect private innovation or AI innovation in the commercial sector. That is, data and the algorithm that's being trained by the data can be shared across multiple purposes within the firm. And this means that there is going to be existing or the potential of economy of scope from government data. Okay, so because the data can be shared across multiple purposes within the firm, when a firm gains access to government data after, for example, providing some services for the government, so that the data is allowed, the firm is allowed to have access to that data. Those government data can be used to develop not only products for the government sector, but potentially also simultaneously for the much larger commercial sector. And to the extent that the data can be shared sort of across the firm, let's get back to sort of the IO side of things, which will govern sort of a lot of the market dynamics. But again, that's not something that we're going to be abstracting away from primarily from analysis. Okay. So I'm going to sort of empirically, we're going to try to document and just to see to what extent is the economic scope of government data is actually relevant in the real world. And to the extent that they are, it's going to have sort of pretty substantial implications. So we're going to focus on one of the leading AI sector, which is the facial recognition AI sector in China. This is a sector at the technological frontier. And facial recognition is one of the key applications across the board for the AI in innovation. Okay, I'm going to show you that after a facial recognition AI firm in China receives a government contract that allows them to access more government data, those data are in the form of video streams collected from public surveillance cameras, the sort of data that the facial recognition AI firm really would benefit from. It leads the firm to produce new software, not just for the government, but also simultaneously producing and developing new software for the commercial market. And I'm going to sort of try to argue and try to convince you that this is a test for the existence of economy of scope and a fairly sort of in fairly large magnitude. Okay.
David, can I ask a question? Is there something we should think about that's theoretic, that theoretically distinguishes government data from other types of data? Because I'm like reading these slides, and if I took out the word government, it seems like these things would probably still be true. So I don't know if there's something theoretically about the nature of the data. I know we're getting to the policy in the next slide. I just want to understand if there's something like unique about this particular kind of data.
Yeah. So certainly it's sort of there are to the extent that data is data, then there and to the extent that certain data in the production function of certain technology, and that's purely substitutable from private data, then there's no distinction in that front. The key distinction come from sort of there are in certain domains. Take the example of the facial recognition domain and the domain of sort of surveillance camera. In certain domains of those type of data, government is almost the only player, and this is not unique for China per se. We're quite far from sort of having any private access to sort of having street camera data. So in the sense that we're worried about data in those domains, the only data that's available in large quantity or meaningful quantity is government data. But there are also obviously domains in which the government data is less well comprehensively collected than private data. But at least for the facial recognition, government data is special and unique in that perspective.
And so, David, you can stop me if you're just going to cover this on the next slide. But the last bullet point, it's a little awkward in that seems fairly endogenous, right? Like if the government has all the data and it's costless to provide to people, then wouldn't everyone ask for the most data they can get? And then what's causing them to give some data to some people, more data to another person, different data? In other words, so it seems like there's some kind of matching, there's some kind of project specific, or there's some kind of organization specific or some institution specific within the sub-government that's giving this data. It seems like there's a lot of other things going on here that need to be understood in order to say this.
Sure. Yeah. So that's a good question. So I'm going to defer the issue regarding endogeneity to a little bit. That's sort of hopefully I will be able to convince you that our empirical strategy can sort of credibly estimate sort of or make that causal statement. That's to sort of get rid of the endogeneity issue. So I'll defer that to a few slides when I show you the precise sort of strategy we use. The one thing I do want to highlight sort of at a high level now, though, which we'll get back to get to a little bit in the next slides, is that in the context that I'm going to study on facial recognition of AI in China, government is not, I think the best way to think about these sort of government and firm interactions is that these are not interactions in which government are explicitly try to provide data. And you can almost think that the data are incidentally provided because the only thing or the direct thing government cares about is to use AI to enhance its public security or its surveillance. And as a byproduct of that, data is being provided to the one or two firms that's been providing its services. So in that sense, it's a little bit different from the government is just try to strategically think about how much data I'm going to provide and sort of what's the distribution of that across the firm. This is saying that my direct incentive is to enhance my public security, surveillance services and so on. And then I need to work with one firm to analyze my data. And that firm who will work with me will have access to my data because he's analyzing it. Okay. But we're going to sort of get to it a little bit when we think about sort of stepping back a little bit to think about the consequences and the trade-off involved in various policies. And we're going to explicitly talk about policies in which data provision is explicit, the goal of that. Okay, so to do this, and hopefully I will have some time towards the end of the talk to go through this. We're going to sort of build or modify a standard direct detection change model. And we're going to, the key modification in the standard model is that we're going to allow data to be an input, and we're going to allow for the potential for economy of scope arising from the government data. Okay, using that model, it's going to allow us to start to think a little bit about both the positive and normative consequences of certain policies. And we're going to specifically focus on two policies related to government's demand for data-related technology and government's provision of data. Both are sort of somewhat relevant if you extrapolate from the context of facial recognition AI in China. So the first policy I'm going to discuss is government's demand for AI for its purposes, such as building a civilian states, as we see in China. I'm going to sort of show you that this framework is going to generate the sort of the conclusion or the prediction that when the government demands more AI for its own sort of public sector purposes, it's going to incidentally promote economic growth. So this is a little bit to my conversation with Lauren. This may not be explicitly being done. It's just because the demand for certain technology data is being spilled over to the commercial sector or to the AI firm. This will incidentally promote economic growth, but this will distort the direction of innovation and potentially reduce citizens' welfare. And this might come both at the source of crowding out resources, but also infringe on citizens' civil liberties. Okay, I'm going to discuss also a little bit about how this can be compared with sort of policies or sort of cases such as space race and defense mapping or dual purpose technology more generally. I'm going to show you that to the extent that incidentally promote economic growth, there are some similarity with those when government for its purposes, and there are also important differences which I'll discuss. Okay, the second policy which we'll discuss is that is government's sort of provision of data to the data that is collected to the firms. I'm going to show you that such policies you can think about these kind of policies as a form of industrial policies or innovation policies could be justified on normative grounds, particularly when the underlying economy of scope arising from those government data are strong enough to overcome the potential sort of war for losses and so on. Okay, if we were to compare it to this sort of policy, government providing data to the firm, there are some similarities or parallel with such policy, with the more traditional sort of policy, such as governments providing for public infrastructure in terms of what will happen there, but also there are important differences which we'll highlight. Okay. Now, let me actually pause here to see if there are further questions before I start to delve into the details and start on the first question. What's the role of government data in shaping innovation?
So I think I see where you're going, but let me just highlight it so that I can defer the question to the appropriate moment. I think in our last conversation, and I still have the same question, you place all your emphasis on data. And I'm very tempted to say the emphasis ought to be on operational experience, that data per se isn't really all that important. It's having lots and lots of experience developing algorithms. And then all the files and procedures and libraries that the firms develop in the process of doing that are capital that they take with them to other uses. And so then to me, that looks like very analogous to a procurement from government procurement, asking supplier to provide something, they get the experience, and then they take their experience with them to some other activity later. And you're going to tell me that that's not necessarily the right way to think about it.
So yes and no. So let me give you two thoughts on that, and then I will also get a little bit about our empirical strategy that I'm going to introduce or describe it in a second. The first one is that we're not going to make a direct or sort of very strong distinction between whether the economies of scope that's arising literally from data, that the same data is being used or recycled for different purposes, or the data gets into a trained algorithm, and that trained algorithm has been recycled across multiple purposes. Okay, so that we're not going to be able to make a distinction, both conceptually and empirically. I don't think it's going to make a big difference. We are, however, going to make a difference of this type of spillover versus the more general learning by doing that you're describing, that I just now know how to do things, and because I work with the government, and that know-how has been transmitted to others. I'm not suggesting, or we're not suggesting, that these are not relevant. It's just that hopefully our empirical strategy is so that even after you're controlling for the potential degree of this learning by doing, this additional layer of spillover that's coming from, you can think about just purely from a technological perspective, the data can be transferred. So in that sense, we're sort of shutting down the learning by doing, but that's not say that this is not relevant in our context at all. And perhaps sort of from a magnitude perspective, this is equally, or if not more important, but we don't have much to say in terms of quantifying that. So which I guess, I'm hopefully I'll be able to convince you that sort of holding fixed learning by doing, there's an additional degree of spillover that happens sort of very quickly because of the data transfer, sort of the shareability across purposes. Where learning by doing, you might predict it might happen sort of with a bit of a lag and so on.
Yeah. So David, just very quickly, given that Shane has launched this ship, let me just kind of throw one more sailor on the ship as it goes out there, and then you can kind of feel free to address then. It seems like the tricky part about doing what you just said you were going to do is that could be many unobservables correlated with the amount of data I give you that could affect your learning. In other words, if I give you more technical support, if I give you more lots of other things, then those things, even not in a repeated game, like a repeated exposure framework, but just the intensity within that exposure might help your learning and you move up a little bit quicker. Even though, let's say it's both of our first times dealing with the government, I just get more data and more resources and lots of other things, which help me move in that direction.
Yeah, you're exactly right, and that's exactly at the core of the empirical challenge of identify sort of or nail down the role of data. Now, again, I would defer this for a few slides, but just to give you a teaser of what our empirical strategy, we're gonna try our best to hold fixed as much as we can about the task you're doing for the government, or even the unit of government you're working with, but only allow the sort of the amount of data the government is, or that unit of the government is processing or has been collecting to vary. And hopefully that the final part is allow us to single out the data. But with the downside of this, because we're zooming into only allowing the data to vary, we're also implicitly shutting down other channels, which may be very well at play in this context as well. Okay.
Hi, David. Can I ask you a much simpler question? Which is, when you say data, should I think of it as the government is just giving you like a data file or that's sort of fixed, or should I think of it as they give you access to a stream of data that they're currently collecting and will keep updating in the future?
So it's more the latter, at least sort of the way I think about this particular context. So this is a good sort of leadway into. Let me give you a bit more sort of background of this context, and I'll get back to this question sort of right after the end of the slides. So we're focused on facial recognition AI in China for two reasons. One is that this is a sector, as many of you might know, is very data hungry. Developing any sort of useful product that's to not only the government sector, but the commercial sector really requires access to a large amount of data. And this, as I was discussing earlier, this is precisely kind of data that the Chinese government has been collecting by a large quantity. And to that extent, many governments are collecting facial data from the surveillance camera. Let me walk you through sort of the example, sort of just in words, about how this interaction between the AI firm and the Chinese government are happening. And I think sort of the question about what sort of data the firms are accessing to is going to become clear. Okay, so think about a facial recognition AI firm that received a procurement contract from a local unit of a local government. Because this is an example of this will be a facial recognition firm that's been contracted to provide data analysis for a municipal police department. Okay. Now, importantly, also this come up in the previous question already. because I'm asked to analyze the data for the government, because I'm an AI firm, this is going to implicitly allow me to access the data because that's the data I need to analyze this on. So there's no way around it. So the data has to be flowing sort of more or less through my firm's server, and then that's how the data is being accessed. What that suggests is that this access, the firm's ability to access the data is in some sense implicit, because the contract is not about selling the data. The contract is about providing services. But the services is about data analysis, so the data has to be coming to my server. But also it means that this is going to be a strings of data. To the extent the local government is going to have a lot of sort of cameras or denser network cameras of collecting a lot of strings of video footage, the firm is going to have more access to more data. And that's sort of the type of variation we're going to be using. Okay, so these are the sort of, for example, the video from street cameras, and the firms will also going to have access to labeled personal images so that they can make sort of matching or predictions depending on the tasks. Okay, so as you can see, sort of how the economy of scope or the spillover could happen. The firm, when they have access to those data, their algorithm of facial recognition could get better, and they could use the improved facial recognition algorithms to provide new services or new softwares or develop new softwares for the public sector, for the government sector. But the exact same data that the firm has not had access to could be taken to develop software for the commercial sector. For example, letting supermarkets sort of detect shoppers and detect their behaviors in the retail space, which is very valuable for the sort of personalized targeted ads, for example, that presumably government have no direct interest in, but very much relies on the same data or the same similar algorithms to develop. Okay.
Right. So the companies are actually allowed to use the data and then build other products on top of that data stream.
So it depends. So this is my discussion with Shane earlier, that we're not going to take a stance on whether they literally use the exact same data and then do it for something else, or they return the data or they can discard the data, but then now they know the better sort of recognition software. They fine-tune the algorithms with better sort of parameters, and that new algorithm is under the firm's own ownership or the property, and then that improved algorithm is something that they take to the commercial sector. Now, even the most restricted environments, such as in Europe, there's no direct regulation against that. It's really hard to regulate who owns the algorithm and so on. So even if you take that stance, you're just pushing the economy of scope one layer above the production chain. But sort of from what empirically perspective, it is going to generate sort of very similar predictions empirically. Yeah. Okay. Let me also emphasize before I get into the context is that you can think of many reasons why economy of scope or the spillover from government data to produce things for the government may not spill over to the commercial sector. One of such reasons might be I just received a large contract from the government. That's one of the biggest clients. I might actually reallocate a lot of my intermediate resources, such as my engineers and so on, to just develop more things for the government to secure future contracts, to secure future revenue streams from the government. That will actually, on the margin, crowd out my innovation activity for the commercial market. Now, to the extent that there is this crowding out to secure sort of the future government contract and so on, the degree to which we're going to observe spillover or crowding in the commercial sector activity is going to be a stronger test for the underlying economy of the scope, because that's going to be on net of these potential forces of crowding out. Okay. So let me talk a little bit about the empirical challenge that Lauren was asking earlier already. There's actually sort of two classes of empirical challenge. The first one is there's actually a lot of data-related challenges of quite a few number of data that we would like to have to be able to do the empirical tests that I just sort of described to you in words don't exist, that we need to build from scratch. We need to have some observation of the AI firms and their interaction with the government. We need to know what the software the firms are producing. And very importantly, we need to know what the software is for, whether it's for government or for commercial purposes. We also need to have some proxy for the amount of data that the government data that I have access to, because that's the key margin of variation that we're going to exploit. And also, we're going to have the more traditional sort of endogeneity or identification challenges. Of course, the firm who get access to the firms who won the government contract is not going to be random. It's not going to be randomly assigned, and so on. So we need to deal with that. And also, as many of you have mentioned, the government contract might come with many things in addition, in addition to data. So hopefully, our empirical strategy can nail just the part of the data access and shutting down variation from the other sources. Okay, so let me describe you the data, and then I'll show you how these come together with using to be able to operationalize our empirical strategy. Okay, so the first data sets that we're building is one that links AI firms in China to their interaction with the government. That actually requires to piece together two different data sets. The first one is that we think we're pretty close to be able to identify the universe of the facial recognition AI firms that's has operated or existed in China in the last decade or so. And we built this from two different sources: a Chinese-based source, Tianyancha, and the US-based one, PitchBook, as a complementary source. Okay, so that gives us about 8,000 firms in this domain. It's fairly sort of skilled in their size. There are a couple of very large ones, and there are thousands of very small ones. Okay. We're going to combine this roster of AI firms with a separate data sets that sort of essentially documents all the procurement contracts that the Chinese government has ever issued in the last decade. And then most of these contracts are in the domain of local governments. There are about 3 million of such contracts, and this is the database maintained by the Ministry of Finance in China. I think the initial motivation for this is to curb corruption, to increase transparency, and then that sort of requires the local government to publicize the procurement contract after a certain threshold, which is a fairly low threshold. Okay. So then we're going to just merge these two. So which allows us to see for each of the facial recognition AI firms, we can know which local government, which unit of local government, and when they won a procurement contract by providing the AI services. Okay, and for the most of our empirical strategy, we're going to focus on the public security arms of the local government. These are local police department, and so on, which have access to or have jurisdiction over the street cameras in a city, for example, and also the sort of the personalized ID database for that city.
David?
Yeah.
So do you know, sometimes there's contracts which are the first one and they're big and they're foot in the door and they're beachheads, if you will. And then there are the other ones that are routine. You already have an established position and you're just renewing that relationship. Do you have a sense of, are you going to be able to have a sense of that?
Yeah, so we're going to primarily focus on the first contract, and precisely because sort of as you said, sort of not only is the timing and the nature of the second contract is a little bit complicated, and oftentimes endogenous of how well you did on your first contract. And the first contract oftentimes lasts for more than 1 year. And again, these are, I think the best way, and a little bit simplifying way to think about this contract, these are not selling a product, these are selling services. So it has to be renewed at some point, sort of duration, because these are the government asking the AI firms to help them process the street camera data. Yeah, but we're going to focus on the first contract precisely because we think it's more likely that the timing of that contract is exogenous, that's exploitable from an empirical perspective than the timing and the arrival of the second contract.
And it also gets at so I get the idea that it's a service, that they're continually doing things. There are some parts of facial recognition that aren't that way outside the government. So, like in automobile production or something to detect people going to sleep, that's on a more yearly cycle and things like that. Will you have a sense of that as well, or for that, particularly when you get outside of the government, that's going to matter more?
Yeah, so that's interesting. So we don't observe by the nature of these procurement contracts how these firms are structuring their services in the commercial sector. They could sell a wholesale platform, and then essentially they're out, and then let the business deal with the platform and use the platform. Or they could also operate under a subscription and service provision model. I don't have actually a good answer of which one dominates in this market, even within facial recognition, let alone outside. But that could be something to look into.
Yeah. Okay.
But I guess to the extent that one of the question earlier, to the extent that from a these firms' perspective, they're incentivized to access more data, and this service provision, this subscription-based service is probably the best strategy for them to secure a flow or continuous flow of data than just a one-off sort of selling a product per se.
David, can you tell us a little bit how important for these AI companies these government contracts are? Are these what makes them survive, or are these sort of a side business?
So it depends on how you count their revenue or their assets. So in terms of the revenue flow, this is fairly large, and sort of to some extent, some of the firms, half of the revenue come from government contract. And this is what I said earlier. You might actually, given that magnitude, you really might predict some crowding out, because that's just such a big client. From an asset perspective, the revenue they get even from the largest government contract oftentimes is dwarfed by the funding they get from the VCs and from the private sector. I don't know actually what's the background of those VC, but typically sort of these contracts are not providing nearly as much of the initial funding for these startups, and that often comes sort of many years before the first government contract. But just in terms of revenue stream, I think this is definitely non-trivial for them. I should also mention it is an industry that's fairly skilled in the sense of among the 8,000 firms, only about 15% of them had at least one government contract. So many of them never sort of end up working with the government. Government are oftentimes just picking the big players, which again, we'll get back to the endogeneity issue of that in a second. But conditionally having one contract, you oftentimes have many more contracts after that. Again, making the second contract and so on a bit complicated to look into. Okay, so that's data set number one. Data set number two that we need to be able to build is that we need to see what the firms are doing or what they're producing and innovating. These are software firms, so which makes our life a little bit easier in this particular context, because it happens that you have to register all your software production with the government for it to be sort of released to the client. So we take sort of all the registry of the new software releases from China's Ministry of Industry and Information Technology, and that's going to be our primary outcome space. Okay, we're not going to be able to sort of cross-check this with the secondary source for all the firms, but for one of them, McAfee, for example, which is the largest facial recognition, one of the largest facial recognition firm, which is going in the process of going through IPO, we can compare the software releases that McAfee is releasing on its own versus the software registry that we have, and our coverage is sort of 100% of what we observe. Now, very importantly, just observing the software releases or the new software production is not sufficient for us to identify economies of scope, because we need to also see the relative ratio between the new software that you're developing for the commercial market relative to that of you're developing for the government sector. Okay, so we need to be able to sort of categorize the intended customers. So we can tell a lot of this from the title of the software already. For example, I'm giving you a couple of real examples here. If the software has the title "Smart City Real-Time Monitoring System to Maintain Traffic on the main traffic routes," we're gonna sort of categorize this as a software for the government. Government are primarily interested in traffic control and so on. If a software has the title "Visual Recognition System for Smart Retail," we're going to call this a software for the commercial market that the government don't have a direct interest in, but you can see the commercial value from things like this. Okay, we're not going to be able to do this all by hand, given that just the volume of the software. So we're going to use a neural network to do the categorization, where we manually sort of code about 13,000 software depending on these categories, and then we would let the algorithms to be trained on this and then categorize for the rest. Our prediction rate is fairly accuracy rate is fairly high, and we can do a sort of not doing the talk, but sort of in the paper we do quite a lot more to show that almost none of the results are affected by exactly the way we do the prediction here. Okay. So that gives us sort of the firm's output by time. And in particular, not only the total output, but also output by with the different intended customer. which again, the ratio between the new software you're producing for the commercial versus the software you're producing for the government sector is critical to estimate the underlying degree of economies of scope. Okay. Finally, and this is the last piece before I will show you the empirical strategy, is that we need to have some ways to proxy for the quantitative data that these firms are accessing. And this is sort of a notorious challenge for empirical work in this space, because we oftentimes don't directly observe the data that the firm has. Okay, so our empirical strategy is going to be to operationalize this proxy, is that we're going to focus on as I mentioned earlier, the contracts that's in the space of public security. So again, with local police department and so on. And then we're gonna zoom out of AI and look at sort of for each of these prefecture in China and their local sort of police department, the procurement that these local police department has been accumulating or has been issued to purchase high resolution surveillance cameras. So these are hardware contracts. Okay, so then for each of the prefecture, by each year, we can then count how dense is the camera network in that particular sort of jurisdiction. And then we're going to call a contract that's issued by a local police department at a year when that local police department has already been purchasing and installed a large number of above medium number of surveillance camera to be a contract that's data rich. Okay, and vice versa to be data scarce. So this is not only varying at the across space, but also across time, because you might get a contract with a local police department 2 years too early before the local police department starts to buy a lot of cameras and so on. Okay, so actually, let me pause here and see if there are actually more questions on the data before I show you the empirical strategy. Let me mention one more thing, that sort of that data richness of the data of the contract is the one that we're going to be able to focus on to try to tease out a lot of the things, additional things that might come with a government contract that's not directly related to data per se. Okay. Questions on the data part?
I'm just puzzled. You originally got all this data in Chinese. When you did the cataloging of all the contracts, did your algorithms work on translated data?
So everything is in Chinese. So yeah, I mean we did everything in Chinese. But once you sort of did the initial categorization, then it doesn't matter which language. But that's also put a restriction on who can be our RA, and they have to be Chinese. So that's.
Looks like a lot of work.
It's I skipped through the first slides of the large team of RAs that's really been helpful on this project. That wouldn't be possible without their help. Noam and Martin unfortunately couldn't help with the categorizing of softwares. Okay, so let me show you the empirical strategy, and sorry for the long overview of this, Lauren, to your question. So our baseline strategy is going to be estimating or using a triple diff strategy. So what we're going to be comparing is we're going to compare cumulative software production, so software sort of development of these firms before and after the AI firm received its first data-rich public security contract, relative to those firms whose first contract is a data scarce one. Okay, so the three layers of the differences that's going to be contributing to this strategy is that we're going to always compare within firm. We're going to have firm fixed effects, so it's going to be before and after the firm received its first contract. So sort of any selection, timing variant selection of the firm into getting a contract is going to be washed out. We're also going to take advantage of different firms going to get their first public security contract at different calendar time. So you can always include calendar time fixed effects. So any of the time variant sort of industry-wide trend can be washed away, because firm A is going to get its first contract in January 2018, and firm B is going to get its first public security contract in December 2018. Okay, and the third difference is that we're going to always compare the firms whose first contract is with a local public security unit of the government that has a lot of cameras to begin with. That the data you will be getting from working with the government is going to be sort of relatively large relative to the first public sector contract that is with a low camera dense sort of prefecture, and hence the contract is data scarce. Okay, so what that means is that this is holding fixed the sort of things that you're doing for the government, because you're always working with the local public security arm. You're doing essentially the same thing of analyzing the street camera data for the government. But then you happen to work with one local government who has really a magnitude more cameras versus another government who doesn't yet have a lot of high resolution cameras. So the data is going to be a bit more.
And David, I should think about that matrix as being full in the sense that there are some firms that go from data rich to data poor contracts, and some that go from data poor to data rich contracts over time.
Sorry, so that's
like every contract that you sign gets better and better in terms of data.
So it's always going to be, so the confusion. So it's always going to be, we're always going to look at the first contract. So the data rich and data scarce is going to be the variation across firms. And since some firm, its first public security contract is a data rich public security contract, and some other firm, their first ever public security contract happened to be with a data scarce contract. They could have, as I said, second contracts coming a couple of months later or a year later, and that could be either data rich or data scarce, and then that's not going to be.
Okay. So the firm fixed effect is not going to help with that. The firm fixed effect is just going to help with other firm characteristics.
Exactly.
In our concept. Okay.
David, can I ask? I know there's some evidence that winning a first contract and demand shocks can lead to increased firm growth. And I think that's why you all have this sort of triple interaction here on is it data rich or not data rich? Yeah. But I would also, I guess I'm just not sure if growth rates would vary based on locations as well, especially if we're looking at high density locations versus low density locations. So that's something you've thought about controlling for, looking at, I imagine if you did the same kind of winning a contract as a lead to growth and did in big cities versus small cities, you'd see differences in outcomes. So I don't know, is that right? And that's how you guys are thinking about it here, and curious to hear your thoughts on that.
Yeah. So we think the triple diff has already taken out a lot of stuff, but there's still residual things you might worry about. We could also include pre-contract firm characteristics, the firm size, the firm age, and then the things that you mentioned, sort of the make that timing vary, so the sort of the firm specific trend and so on. We can also control for location specific time trend in a specific area. It really doesn't do much, and then we can also sort of exclude contracts that's issued by sort of cities of Beijing and Shanghai, which would have the largest commercial value for the firm. In fact, our triple diff is really going against that. I'm going to have some evidence to show you. The local government that has a lot of cameras or a lot denser camera networks are not the richest sort of government, local government in China. There tend to be more peripheral government who have more political risks. And Beijing and Shanghai don't have nearly as dense of a camera network than some of the other places. So if purely for the commercial potential and so on, the data richness of the contract actually is biting against those firms per se. But
I guess I'm just wondering, in some of these papers that look at demand shocks leading to growth, I think there are a number of within firm mechanisms in terms of hiring and capitalization, capital raise and stuff like that. So I don't know, it'd be interesting to kind of try to address some of those other mechanisms and link it to this measure. And because again, I think there might be some variation based on location too. Yeah. So, and in those studies they're doing, they're controlling for everything. Where do we basically have what looks like a random win of a contract? And from that point on, you see separation in terms of firms that win and don't win. So that's sort of more what I'm curious about.
Yeah. So that's a point well taken. So we also, again, we control for a few, but there are always things that we don't control for. The one more thing I should mention to you is that not only this has to go through the triple diff specification, it's also that the primary things that we're interested in is not just your production for the government or even the level of the production, but it's the wedge between government software production relative to the commercial sector software production. And you're going to see that sort of the speed and the magnitude of which the commercial software production picks up after winning a contract at least in a very short run, meaning that a lot of this sort of the demand side sort of factor is probably not yet enough to kick in because it just happens so fast. Where sort of, if you take the data and then let the data run on a different algorithm and so on, that could happen instantaneously. Okay. Any more questions on the specification before I show you the result? Okay. So let me start show you our main results, which can pretty much be summarized into 6 different figures. I will show you sort of the government software production cumulative. So at each unit of the time here is a Same year. That unit doesn't really matter here. Per se, we can use longer or shorter window of that. I mean, so the 2 figure that you're looking at right now is the AI firm's software production for the government purposes, sort of leading up and after the first contract. First, if the first contract is a data scarce contract with a local government that doesn't have a lot of cameras, versus in the second graph here, which is a data rich contract, the local government, local police department has a lot of cameras. Okay, so the 2 things to point out here. One is that if you focus on the data scarce contract, what you see here is that there's no pattern of pre-trend. So leading up to the arrival of the very first contract, the firms are not differentially producing more relative to other firms. But almost immediately after the first contract arrives, already within the first summer year, the firms start to produce more for the government. This is true for if the first contract is a data scarce one. That data scarce doesn't mean there's no data, that it just means relatively less data. But for a data rich contract, you see the same pattern, but the sort of the slope is a little bit steeper. The increase in government data production is faster in that sense. Okay, so if we do this triple diff coefficient, comparing the relative increase of data rich relative to the software production increases after arrival of a data scarce contract, I'm plotting in the third figure here that difference coefficient, and you see that again, there's no differential increases across the contract data richness leading up to the contract arrival, but it starts to widen and opens up after the contract. So in other words, the firms are producing more for the government, in particular after the arrival of the first data rich public security contract. Now, perhaps you can say after these 3 figures, this is not sort of surprising per se, because again, this is my answer to PR's question. These are large revenue streams for the firm, and they better produce something. Probably the contract is already sort of implicitly sort of ask the firms to produce something or develop some new software for the government, and then we see this for the government sector. Now, what's going to become sort of ex ante ambiguous is what happened to the commercial sector. Are the firms actually crowding themselves out from producing for the commercial sector because now they're devoting a lot of their energy and resources to produce for the government, or we actually see a crowding in? Okay, so in the bottom panel here, I'm showing you the equivalent of what you see earlier, but just replacing the government's software production as an outcome to the commercial software production as an outcome. Okay, you see a pattern that's quite similar to before, where there's no pre-trend of the firm's software production leading up to the software to the first sort of public security contract, but the firm start to produce more, again, almost immediately to the commercial market after that first software increases, that first contract arrives. This is true not only for the data scarce contract, but also for the data rich contract. And the data rich contract is shifting the firm's commercial software production even higher. So the triple diff coefficient is positive throughout. Okay, so this is suggesting,
Yeah, sorry. If I take the causal estimate as the one in the third column, so the difference, right? Is it reasonable that the effect shows up and it becomes significant so much later, 5 years later, 6 years later?
So it depends. So we see the sort of the double diff sort of there's some action about the firms start to produce more. That happened obviously.
Yeah, but it's a government contract that is a lot of money for them. So as you said, these companies are receiving a lot of money. They may be hiring more people because they now have a lot more revenues. They may just be growing. So that contract is not really the data that it's leading to this new innovation. It's the relationship with the government that is a signal of quality, that is an influx of revenue. It's a lot of other things that may happen that lead to. And so that's why I was focusing on the triple difference. I like that because you have a way to sort of disentangle really the role of data. But then if I just focus on that difference, then it's not a huge effect.
I see what your point. Yeah. No,
It's semi-years, Kiara. So it's not 5 years. It's 2.5.
Oh, 3 years. Sorry. Yes. 3 years. Oh, okay.
Well, but your point still working in the sense that we don't have a particular ex ante stance on should this happen in 6 months or is it a 2-year a watershed moment where things start to jump up. So that it is what it is in the sense that we see things are subject to the power issue, but it really seems to be power enough to identify these positive things after about 2.5 years. Now, one thing I do want to highlight here, which is a little bit sort of hiding in this figure, is that if we interpret the ratio between the increasing government software production to commercial software production as the key parameter that linked to the economy of scope, that's that in terms of the magnitude. So every 3 unit of additional software you're producing for the government, that's crowding in 2 additional units of commercial software. This 2-to-1 crowding ratio is actually fairly stable throughout. It just both denominator and numerator are low, and it wasn't specifically sort of detectable in a powerful way in the beginning. But this 2-to-1 ratio is fairly stable. That jumps that starting merge from the first time that year. But again, I don't have a particularly strong stance on when do we think this is going to happen. So is 3 years a medium term or short term from an innovation perspective? Not clear from this context.
I don't know. Thanks, though.
Just to follow up to that, do you have a feel for what most of the commercial applications are? Like, are they ad tech primarily?
So one of the very salient ones that's the example I showed you is for the retail space. And the usage of that is to recognize without knowing who I am, but to know this, David comes into a supermarket and know that I like to buy X and then always go to buy X first. And that's very useful for them to do individual marketing. And that's the one thing that's one thing that you see a lot of commercial application. And the other one will be face recognition, supermarket checkout, scan my face and do my payment without me putting a card in. And that again, so be able to scan my face and link my face to my identity. You can see the linkage of that to the surveillance camera that the government is using, but this has obviously commercial applications as well.
David, are they sometimes able to use the library of faces, or are they only able to use it for training? Like, could I get and maybe it depends on enforcement and things like that, but if you build a database of everyone in the city, you could then identify new customers in retail space. Is that something that's like strictly prohibited by the contract?
So my impression is there's no sort of proof per se, but my impression is like these firms are allowed to have access to essentially the local ID system at the very least, and that's partly because depending on tasks that they're asked to do by the local police department, some of them requires you to find out exactly my faces, and then I need to the AI firms to help them find out where that person is, and that requires them to have access to ID system.
But
and
they don't have to silo that in the government application from the commercial application. They could share across the two. That's what I was wondering about.
So that's a trickier question in the sense of if they sort of somehow build this into the algorithm, and that doesn't need them to call into that raw database, then you can imagine this to be used directly for the commercial sector. This is going sort of way beyond what I know for the exact sector, but you also might imagine that the algorithm is essentially a bridge, and then the commercial sector bring their own. If I have access to your bank account and everything, I know your ID already, and I just need a bridge to bring that system to a face that's in front of the cameras at the moment, and that may also be just sufficient for the commercial applications.
I have a question for you about this ratio, which is really fascinating, the government to kind of commercial ratio that you were bringing up earlier. I'm wondering if you have a sense of what that would be outside of this context. So, and maybe you're going to talk about this when you talk about how this might be different than defense spending, but I'm curious if that ratio is consistent across other kind of commercial to government contracting that occurs.
Yeah, so the short answer is we don't know, and I can give you some speculation of what direction this could vary. You can think about this as, and part of this exercise is to demonstrate sort of almost as a proof of concept. If you were to go out and try to estimate this economy of scope, which hopefully in a bit I want to sort of be able to demonstrate, this is a very important number to be able to estimate. This is sort of the ratio empirically that's observable and that's important. Now, what that ratio will look like for a non-facial recognition sector outside of China or in a different sort of AI technology, we think it could be depends on the regulation, which is a little bit related to our discussion with Alex, that if certain environment where it's really prohibitively hard for you to use anything related to government data on commercial applications, that doesn't mean this is all going to go all the way down to zero, but it could potentially shrink this ratio. The technology itself can also play a role where the degree to which government is actually productive in producing things for the commercial sector can differ depending on whether it's facial recognition or speech recognition and some other things, just from a pure technological perspective, and that can also govern this ratio. But we don't have we don't have any more educated guess on what this number will be for different contexts. So, but we think it's important to try and go out to estimate this number beyond this particular context for sure. And you're going to see in a bit that a lot of the discussion on both the positive and in particular on the normative implications of some of the government policies related to their data, it quite depends on how large this ratio will be.
Yeah, it's interesting. I was kind of picking this up in a little bit of a different way. I mean, outside of this context of facial recognition, it might be interesting in China to understand what the relationship is between government to commercial contracting to see if there's also a similar effect outside of kind of facial recognition. So maybe to help to get to kind of some clarity around some of the questions that were asked prior about, is it really just the government that's kind of helping to induce this change in the commercial sector, or is it something very special about this setting around getting access to data?
Yeah. So that okay, I see your point here. So that's definitely true. So to the extent that there might be crowding in, or in many sectors you might imagine crowding out, and regardless of in a non-data related sector, when you work with the government, how much of that spill over to the commercial activity to the firm, one can definitely estimate this number and sort of try to benchmark this against that. Our triple diff sort of, in some sense, we can compare this ratio from a double diff relative to the one from the triple diff already. Try to get, because the triple diff ratio, as Kara said, really is zooming into just the data part of the role that data is playing. But we can zoom out of this and see the overall sort of working with the government and how much that's pushing the firm to produce for the government sector versus the commercial sector. And that's something we can already do in the AI sector, but it could be very interesting to look at benchmarking it with a non-AI sector. Okay. So let me show you two more additional piece of evidence to hopefully further convince you that it's the data that really seems to be important here. The first one is you can think about this as almost like a sanity check, that if the data, the amount of government data the firm has access to really is important for the facial recognition AI firm's software or production overall speaking, and the firms themselves being sophisticated, we will be able to, we ought to be able to observe some patterns in the bidding process where the firms are sort of lowering their bid so that they can maximize their chance of getting those contracts, because the amount of data that's going to compensate for the lesser revenue that they're getting. Okay, we will see some of such pattern. We don't have bidding data for all the contracts, so this is going to be just a subset of them. So we're a bit power constrained. But broadly speaking, if you focus on the left panel here, you see a downward sloping pattern of the bid price the firms are submitting relative to the data richness of the contract. We're using the exact same measurement of data richness, which is the camera density in the local jurisdiction. And this is even net out from fixed effects, in the sense that the same firm are submitting lower bid for a contract that's with a data rich sort of like a local government that has a lot of data. Okay. What this also suggests is that purely, if this is sort of purely about capital or revenue the firm is receiving, data-rich contracts come with less of that because the firm are bidding less on average. So that's also sort of making the data part a bit even stronger on net in our primary estimation.
David, I'm curious, why did you normalize the number of cameras per million residents? I mean, data is data, and so the more cameras you have, the more faces you have.
Yeah. So in fact, it actually ended up not matter much about sort of just doing total count of cameras, so camera per residence, or camera per sort of per size.
Got it.
Ex ante, the reason why the pattern here really doesn't matter. Ex ante, we didn't have a strong stance on whether it's having a lot of faces versus having a lot of faces for the same person, which really helped with accuracy per se, which density starts to pick that up a bit more, which one sort of is more relevant. But it turns out that it doesn't quite matter which one we used as a proxy for data recognition.
Got it. Thanks.
David?
Yeah.
I'm sorry. Just very quickly, this pattern could also be consistent with production costs for data scarce contracts likely to be greater. For example, if you have to put more resources in terms of algorithm training, or even subsidize your own data to compensate for the fact that the data are scarcer.
I see. So interesting. So my prior would actually go the exact opposite, in the sense of, if you might think about working with processing or analyzing large amount of government data is more costly, and I need to buy more servers and to process that and so on. That might go the opposite direction. But I agree with you also that if that put a very strong constraints on demanding my algorithm, that might be a little more demanding, and I want to come to something. So I guess it's ambiguous.
Hey, David, you probably want to control for competitive effects here, right? So more bidders generally lead to lower prices in these procurement contracts.
Yeah.
And so showing both of these together is, it's kind of interesting. So maybe what you want to do instead is show like price versus number of bidders, cut by high density or low density, just to show that it's like dominating throughout, because it's a little tricky to see on the graphs if it's not just, okay, for some reason we have greater entry in these markets and that's driving down the prices.
Yeah, and in fact, we do see more bidder for the rich contract. So I'm not gonna, and I guess precisely the reason why I'm putting this side by side of the bid price and bidders is that I don't take a stance on which is causing what. It's just that the firm seems to be sophisticated enough to know that those high or the data rich contracts are more valuable, and they're going for those more, and that drive down the bidding price potentially, and with more competitive bidding environment. It's exactly as you said.
Yeah, I just don't know if that's I think in an equilibrium like model of entry with the auctions, it would just be that the entry costs are lower, driving that, or the returns would be higher on the back end. But yeah, and anyways, I think you could show that. I think there's a way you could show that kind of in a cleaner way. Yeah. I agree with that.
Like another way to ask Alex's question, I think, is, it may very well be that the high sort of number of cameras per resident are in Beijing and Shanghai. And that's where you have a lot of competitors. And so more number of bids and lower prices. Mm-hmm. So you would have this sort of spurious correlation by just showing those row plots.
Yeah, I see exactly. Yeah. Okay, so that's for on the bidding pattern side. Again, our evidence is to take to the graph I show you, in addition to the comments that's been raised, with a grain of salt, because the bidding data really is not complete for all the contracts. It's just a subset. So that's why I just suggested that the data richness really seems to be capturing something here. The next piece of evidence, or the final empirical piece of evidence I want to show you, is that if we zoom out of the AI software just thinking about sort of the intermediary output that the firms are producing that help them to process the data. If the firms are getting a particular data-rich contract, we should be able to see some of the action there as well, in a sense of like firms are producing more to allow them to store data, to transmit data more efficiently, and so on. Those broadly data complementary software and platforms should be also increasing and especially differentially so when a firm receives its first data-rich contract. Okay, so I'm repeating my our triple diff specification, but this time on as an outcome on the data complementary software, data storage, data transmission software, and so on. So you see that again, no pre-train leading up to the first contract, but then relative to a data scarce contract, the data rich contract is leading the firms to produce differentially more of such data complementary software. And we think this is really sort of quite directly suggesting that firms is accessing to a large amount of data, government data that they previously hasn't, and they have to sort of ramp up their data storage facility and so on to be able to handle those. Okay. All right, let me pause here. I'm skipping this part given the time about sort of various sort of check on robustness and then alternative hypothesis, just not to bore you with. But let me pause here on this empirical exercise before I sort of take the last 10, 15 minutes to talk about sort of the more general sort of the policy related discussions.
Very quickly, I really like the previous graph that you presented in terms of the data complementary software. So if you do this for the non-data complementary software, just judging by what I remember about the coefficient, the magnitude of the coefficient, will that be almost flat? Because sort of this is probably like 2 to 3 or something software differences. So if you do this exact exercise for non-data complementary software, commercial software, what the pattern looks like?
By non-data complementary commercial software, you mean commercial AI software, or so what are the non-data complementary? So these software actually are not AI software. They're software produced by this AI firm, but I don't think they're sort of directly related to AI per se, because these are sort of data storage sort of platforms and so on.
Oh, I probably misunderstood your exercise. I thought so previously the triple diff that it shows for commercial use software, I would imagine that one way to disaggregate, even further separate those commercial use software in your economies of scope analysis is to separate those commercial software that are really data hungry versus those software that are not very data hungry. So I thought that was the exercise we're doing. Therefore, much of the triple differences in commercial use is driven by data complementary software, but probably I'm mistaken.
Yeah. So sorry for the confusion. So these are data complementary software that we think are sort of general purpose in the sense of they could be used for both government and commercial. I mean, these are really intermediate input that then go into commercial software or government software production. Now, along the line that you're stressing, we actually do have, I don't have a slide for that, unfortunately. We do have something along that line. Is a particular type of facial recognition AI software that's very data hungry and data demanding is anything related to video predictions, video tracking. So that in the industry, they call it end-to-end, anything that involves end-to-end matching the video streams to another video streams. Those are very, very data hungry, and relative to matching image to image. That's one-to-one matching, for example. So we see that the commercial AI software that involve video in it are particularly increasing more after the arrival of the first data-rich contract. So that suggests sort of, again, they're getting more into this high-quality, maybe sophisticated AI software space after those software.
David, I have more a question about what you call economies of scope. So, if I'm a company and I do a satellite for the government and then I sell it to a private company as well, that's not called economies of scope. It's the same product and I sell it to different customers. One happens to be a public sector customer. The other one happens to be a private sector customer. Is this what's happening? Or can you really separate a different use of this, like a different software for a different use, or is it the same software to just a different client?
Yeah. So that's a good question. So my quick answer is that a software for detecting sort of terrorists or criminals on the streets for the government versus the same company developed a software to recognizing customers or tracking customers in the retail space. Would you call that a different software or the same software for different customers? So I
don't know.
We're calling this two different software, and you sort of, it's not literally you just repackage everything and sell it to the supermarket. It involves a bit more development, and the algorithm needs to be tuned in a different way. So we saw that those are two software productions and so on. Now, there are probably some software that's more just of repackaging per se, and then without really getting to the deep of the core of the software, which we cannot, given the data availability issues, it's really hard to sort of really to take out those parts. But my impression, looking at the software description, is there are more of those in a case that's described where the difference seems to be substantial enough that they're just not just repackaging per se. So.
Thanks.
Okay, for the last 10 minutes I have, and let me sort of briefly talk you through some of our thoughts on what this means for our thinking about the consequences and various trade-offs that's involved in different state policies that will become increasingly relevant in data-intensive economies. Okay, so given the time, let me actually let me skip sort of the the brief sketch of the model, and I will jump to the punchline. And then if something is unclear, I'm happy to come back to these elements. You can find more details of that in the paper, but let me give you a brief introduction. We're taking sort of the standard sort of Dorona-Smogo 2002 direct detection and change model. We're going to make the two tweaks into that model. The first tweak is that we're going to allow government data to be, or data in general to be part of the production function. The government data can be used to produce for government software, and data can be used to produce for the commercial software as well. That's the first tweak. The second tweak is that we're going to allow for the possibility of economy of scope. And the way we're going to model that, following the tradition of the literature that define economy of scope, is that for the commercial software production, FC here that you see towards the bottom of the slides, not only can you produce that using private software, but you can also produce that using government software. The private software and the government software are gross substitutes, and to the extent that you can substitute the government software to the commercial software, government data to the private data, that's where the economy of scope is going to kick in. Okay, so that's the two modifications that we're going to make to the framework, and everything else is fairly standard. Okay. Let me skip some of the equilibrium discussions, and then I will sort of, some of this will become a bit more clear when I talk you through the policy. Now, the first policy that we would like to focus on, using the lens of this model, is a policy that think about sort of a government that demands sort of AI, not explicitly for the purpose of data provision or data sharing, but for the purpose of some functions, such as sort of using AI to support a civilian states. Okay, we see sort of, states are engaging in certain degree of monitoring of the citizens and civilians across the board, but potentially more so in certain civilian states, and then we see some of that certainly in China in terms of the amount of AI that's been deployed by the public security sector. Okay. Now, we would like to be able to highlight not only the sort of the economic trade-off that are faced in this space, but also sort of the non-economic, non-pecuniary trade-offs. So we're going to modify the household utility. In addition to sort of the household care about consumption, we'll allow the household to also care about sort of big G, which is the government civilians, or government expenditure on civilians, and we're going to allow that to be flexibly to enter to both positive and negative. That's going to capture the idea of citizens might prefer possibly a certain degree of government civilians because that provides public security, lower crime rates, sort of no terrorists, and so on. but also the government surveillance might come in negatively because that's going to be a potential infringement on civil liberties and so on. Okay, so the coefficient delta and psi is going to govern sort of the relative sort of relative weights of the consumption part of the utility versus the government expenditure on civilians, and the civilians part of the government is sort of built out of the AI. Okay, and note that sort of when delta G is bigger than psi C, this is a situation where the marginal utility of government civilians using AI is strictly negative. That there's on net no consumers don't like that on top of the consumption per se. Okay, I want to show you sort of highlights the first sort of a positive result and second sort of a normative result. The positive result is that the firm level result I just show you empirically, that when a firm receives access to government data, the firm can sort of benefit from it by innovating more. This can be aggregated to the economy in the sense of when the government expenditure on data increases, so the government expenditure on civilians increases when the government sort of are spending more on building civilians or public security using AI. This will aggregate and will have aggregate consequences, and it's going to increase the growth rate of the whole economy, and it's going to start to shift the direction of the innovation towards the data-intensive sector and away from the non-data-intensive sector. So it's going to change the direction of innovation in that regard. Okay, this is a positive sort of positive meaning non-normative statement for this. Now, the normative implications of the government's increased expenditure on civilians is going to be slightly more complicated. So what I will draw your attention to first is to focus on the solid curve here. This is showing you a sort of the second-best warfare with respect to the amount the government is spending on civilians, and using a particular parametrization of the model. So this is just not a quantitative sort of exercise, but really just to demonstrate the different forces as a proof of concept. So under a particular parameterization, which we think is fairly reasonable, focus your attention on the solid curve here, which is the situation where the only thing the consumer cares about is consumption. They don't have any positive or negative utility per se with respect to civilians or government expenditure on public security. So the only thing that enters the consumer's utility is consumption. Now, even with that consideration, it's already fairly complicated in the sense of the curve is inverse U-shaped in the sense of there is a domain in which increased government expenditure on civilians is going to increase consumers' welfare. The growth effect is going to dominate. The consumer is going to enjoy that. But then there is a threshold after which there's an over expenditure on civilians that the consumer is going to be worse off because of the crowding out of the resources that's would have been produced for the consumption good, but now it's being shifted towards producing for the innovation in the innovation sector or for the intermediate. Okay. Now that's not even considering sort of the non-pecuniary sort of consideration of consumers' welfare. If you were to start to think to allow for example, consumers care negatively about government civilians because, for example, on net the infringement of civil liberty dominates, which is the situation, the simulation of the long dashed line here. You see that there's no expenditure the welfare maximizing expenditure of the civilians will be zero. Any further will be overexpensed. And then in the solid, in the short dash line here, the final line, which is allowing for the consumer to have on net positive utility derived from public security expenditure by the government. You see the curve is essentially shifting to the right, which means sort of the threshold of over expenditure on the government civilians is getting higher. So consumer benefits after a certain threshold, that threshold gets higher, and still there's a domain in which the consumer losses will be worse off after that. Okay, so this is to recap. What this is suggesting is that in non-benevolent sort of civilian states could, because of the expenditure on public security, could incidentally promote economic growth. But this would distort the direction of innovation, and this could reduce the consumer or citizen welfare not only from the resource crowding out perspective, but also because of the civil liberty infringement that the consumer are finding sort of distasteful from their welfare perspective. Okay. Now compare this to how we think about sort of parallel of this with the situation of space race and the government spending on the expenditure on defense spending. The extent to which those expenditure on space race and defense facility could incidentally increase growth rate. This is sort of where the parallel sort of lies in. And in that sense, sort of the government putting a lot of expenditure on putting AI into the civilian system, that instantly generate more growth rate is exactly sort of the situation with the space race and defense spending situation. But the dissimilarity lies in where the underlying sort of the normative consideration could be much more complicated in the civilians case, where the consumer might have a direct case against civilians because of civil liberty infringement and so on. Okay.
Can I be the devil's advocate here for a second, though?
Yeah.
It is possible, though, that machine vision will be more beneficial for consumers than a space shuttle, and so that net benefit may, again, I'm trying to be the devil's advocate, but may outweigh the reduction, the harm that comes from the direct harm that comes from.
Yeah, I agree with you. So I'm sort of skipping this a bit quickly in this simulation, but if you focus on the short dashed line here, that's the parameterization where the net utility coming out of the public security AI expenditure is positive. So on net, consumer actually like that because it's more safe and so on. Now you still have a threshold where there could be over expenditure, and that's purely not because of civil liberty, because that's not net at all, but it's because of the crowd out of the resources. But so this is just to highlight the normative sort of evaluation of some of these expenditure sort of government spending on civilians is complicated, even without considering consumers of non-pecuniary sort of parts of the utility. And it can get even more complicated once you bring that in. And we accidentally don't even have a way to think, is that strictly positive or negative? As exactly said, it's complicated on that trade-off. Civil liberty versus public security and so on. So for sure, it's complicated.
Yeah, and just to say on the other side, civil liberty may not even have a price. Like they should just be there.
Yeah, so it will be sort of dominantly negative for that term when it enters. So this is really just to show that, again, I would repeating myself. Depending on how that term enters, that threshold of potentially over expenditure on civilians really can be shifting across the board. Okay. I won't have time, unfortunately, given I'm out of time, to show you sort of in detail the second takeaway. The second example along linking this to sort of infrastructure expense or government sort of data provision as kind of providing for public infrastructure. But let me just give you the punchline. Government data provision, as you can think about that as a form of industrial or innovation policy, could be justified, especially if the underlying economy of scope are strong enough to overcome some of the negative parts of the utility. And that's what puts this on one part similar to the public infrastructure, where the states might have a good technology, a good reason to provide that data to the private sector. And that's where the parallel lies in, but also the normative implications can be very different because of the potential infringement of civil liberty that might not be there similarly when we think about public infrastructure type of policies. Okay, let me end the talk quickly. That hopefully I convince you that there are empirically relevant evidence of the role of government data in sort of stimulating innovation, especially in the commercial sector. And I show you that this is coming from a particular channel of economy of scope arising from government data. I briefly mentioned a few sort of policy related implications. And and sort of the similarity and dissimilarity of thinking about government data provision and government procurement of data intensive technology in the data intensive economy, how that could differ from the policies that we're familiar with, and then there are parallel there, but the normative implication can be very different. Let me end here, and I'm happy to discuss more. So I apologize for the bad time management and skipping through some of the latter part.
That was really an awesome seminar, and let's at least give you a round of applause.